FasTech seminar series hosted by FH Sales. Thank you guys for joining us this afternoon. We're going to be spotlighting battery technologies for the future with Zeus battery. Our speaker for this seminar is Peter Foret. Peter is the Chief Technology Engineer with Zeus, where he helps drive the latest battery technologies and educating Zeus customers. Everyone is muted, so please type any questions that you have into the meeting chat, and we will monitor those and answer them at the end of the presentation. And we'll make sure we answer all of them. And Peter, I will turn it over to you.
Okay, sounds good. Everybody, welcome today. I'm not sure where our audience is, located, but let's start conversation about the trends in the battery technologies. So what's driving the different trends and new battery technologies? It's these are kind of the key drivers behind behind the growth in the battery space. Energy growth of energy storage systems, whether it's commercial or the homes, grid management, uh, robotics, and all the AGVs and the AMRs, automatically guided vehicles and automatic material management robots. Electric vehicles, everybody knows, the big players out on the market, they are also driving some of the new technologies in the market. Uh, Portable devices, of course, everybody has phone and a laptop and maybe a smart watch and some monitoring devices around the house, potentially cameras and uh, some others. So it's all consumer market driven. Drones and medical. Drones are becoming key items in also monitoring and also in a commercial and military space and in medical space. Many devices have to have a backup or are portable, and they are being powered by some sort of batteries. Safety and protection, all the alarm panels and all the security devices out there. Fire protection will have many products with batteries in them. Transportation, you have a hybrid transportation vehicles, and you have also uh, movement around the globe. They'll try to electrify a lot of these shipping boats, and batteries will be also using a backup on the trains and for main main um, a power, for the trains, or a hybrid type of situations. Backup, obviously, many companies are using backups, whether it's data systems or whether it's hospitals or in any other institution or application that needs a UPS. Those are the key drivers on the market. The new development drives, drivers are, we all need higher energy density, more power in a smaller space, so everything is becoming portable. Or in a general, we need smaller batteries with more energy stored in them. Another key item is fast charging. Many applications, electric vehicles obviously is one of them, but also robots that they need to run at 24/7, or any device that needs to run 24/7 needs to be recharged quickly. And the fast charging is one of the key drivers to on the market, how to provide batteries that can charge fast. higher discharge rate. Some applications that need extremely high discharge rates, a lot of power in a small amount of time. Safety, they need to be safe. Batteries, especially lithium, are the culprit. We see some of the Tesla vehicles that burn down. It is a real issue in a real world that some of the technologies are safer than others, and the safety is a key driver too. There are different ways of addressing safety. Longer cycle life. Everybody wants battery to last forever, right? When you have a phone that you're giving out a phone, or getting a new phone because the runtime is short, and it's hard to replace the battery because you need to go to a special place to get it replaced. Same about any portable device. So longer cycle life for batteries is that it's required for two reasons. One of them is we don't want to flood the recycling centers with used batteries. That's one of them. And another one is, in general, it costs money to replace batteries, right? Availability of raw materials. Some batteries need very specific metals and materials that are only available in a specific locations on a planet. Cost is a big driver of new development. We obviously, like in any type of technology, the battery cost needs to come down, and the higher volume and more available materials and raw materials are driving the cost down. Batteries also need to be environmentally friendly. Some battery technologies are not very environmentally friendly, and some of them are, middle of the way, and some of them are very friendly. Also, the batteries, we require that have or help to kind of diminish the carbon footprint. Yeah, some of the, this kind of dry, but there's some battery innovations and trends. They are not in any particular order. Okay, here just a list of what's out there and what's being worked on, and it's kind of either on the market, very new, or it is getting to the market. Rechargeable zinc air batteries, and also very large number of cylindrical cell sizes for dominantly the lithium type of batteries. Most common cell in the lithium space used to be a 18650. Now there's a whole slew of them, but some of them, the 1860 was too big. So we scaled down, for some portable applications. We developed, 14500 and 18500, and there's some even, like 14250 and other type of cans that are out there. And on the big size, the 46800 is kind of making it to electric vehicles dominantly. Silicon anode is another type of technology that is addressing in the future some the capacity and discharge rates limitations. Another driver on the market is using less cobalt. Cobalt is pretty scarce around the planet, and they'll be trying to replace it with another materials like nickel or manganese and other. I have slides on that later in the presentation. I have one slide on that particular subject. Lithium LFP is called lithium iron phosphate. It's replacing other lithium batteries because dominantly it doesn't need nickel and it doesn't need cobalt. Solid state batteries. You're going to hear about solid state batteries in a very near future. Some car manufacturers are making headways with solid state batteries, but solid state batteries will make it to I believe, into just about every aspect of our lives in the future. The premises is that they provide better safety, and also they'll provide a higher energy content in a smaller package. Quick charging. We talked about quick charging. It's a big deal. The electric car drivers, people that drive electric car, know it's a painful, to wait for a car on a long, car to charge on a long trip. Another issue, that drives, the innovation in the battery, market is lithium ion has inherent internal short issue due to a growth of dendrites. This is an issue with any type of current lithium technology, and some of the ways of dealing with it is putting passivation kind of additives, into the battery technology that is inside the batteries. Lithium ion sulfur, it's a new type of, it's actually not new, but it's a chemistry that can double or triple the energy content in our current batteries. It's a long wait. It's been in the R&D since about the early 90s, and it is close to being introduced to the market by a couple of companies that have been working on it for years. Pure lead, we talked about lead, not being very, very environmentally friendly, but we found a way to recycle a lead. So we have a batteries now called pure lead out there that kind of address many shortcomings of other leaded types of batteries. Sodium ion is another type of battery that or chemistry that is really nice because it has high availability of the raw materials on the planet. Sodium. Good for solar and wind because they will never become very small because the chemistry has limitations, but they'll be inexpensive and highly attractive to people that do storage in the ground and in the houses or in solar and wind. Some futuristic technologies that are up on a near horizon are lithium air and lithium peroxide. Our company, Zeus Battery Technologies, is involved in many different types of batteries, most of them, and it's a primary batteries, which are the throwaways, and we have some exotic ones in that space. But primary batteries, as per recent decades, really did not have any breakthrough in those chemistries. Okay, rechargeable, on the other hand, had a phenomenal growth in all the spaces, and some of these the lithium is dominantly is almost dominating the market. It's finally kind of exceeding the overall energy storage that was out there in the lead acid and nickel metal hydride. So in the rechargeable lithium, we have several different kinds: lithium ion, lithium polymer, lithium iron phosphate, lithium titanate, solid state lithium. Yes, we have a solid state lithium now available in limited quantities, but they are in production. Nickel cadmium, it's getting out of market because it's not environmentally and human friendly. It is a poisonous material that is hard to recycle. Nickel metal hydride is technology that it's out there, and it will be out there for still some time to come. And still lead acid batteries, which this whole slew of them that you can hear: AGM, VRLA, pure lead. They are all sea lead acid batteries. The battery markets that are out there, not only for Zeus, are for everybody. Where batteries, play are a factor. Those would be, the medical, health, IoTs, and wearables, fire and safety, industrial applications, robotics and AGVs and communication. Obviously, you can it can get more granular, but these are the key markets and that the batteries sit in. Talking about how we at Zeus are on the top of these the latest technologies and growing those technologies in different markets. Pure lead and pure lead carbon is it's a technology that evolved around the regular SLA, except it improved the SLA. It improved the SLA in many different areas. The sealant acid. It improved it in a overall life. This battery can be in a standby use up to 20 years. It also a number of cycles, how long the battery, in a cyclic application, how long can it last? It can typically last 2 to 6 times longer than regular sealant acid. Another advantage of pure lead is it has very long storage life of about 24 months, where regular SLA will be somewhere from 6 to 9 months, up to 12 months on a bigger types. These batteries can also provide a quick charge, where regular lead acid doesn't do that. And also it replaces the overall cost of replacement. Actually, it basically the ownership of the battery. It cuts it down to about 50% of a regular SLA. Here are some good examples of some of the pure lead batteries available, and the key markets for those. And again, this is the improvement, in that technology over a regular SLA or any lead acid battery. It's suitable for automatically guided vehicles, commercial and residential solar, and as I pointed out, for material movers in the warehouse, and high rate, data centers, emergency power. And because these batteries also provide tremendous discharge rates, they are good for electrical starting systems. Traffic controls, backup, and railway signaling would be another application where they do really well, because the operational temperature range exceeds of the one that is available from any other LED technology. Grid stabilization and off-grid power are another two applications that these batteries are really good at. Solid-state lithium, it's a key technology looking down the road in the near future. The number of companies that have been working on this technology for upwards of 15 years, and they still do not have a commercial viable battery. We do have commercially viable batteries right now, and some of the advantages of the solid-state lithium-ion batteries, they can work in very extreme temperatures, from minus 40 degrees C to 115 degrees C, meaning, this battery can actually, sitting in a pot of with boiling water and operate normally. Also, this technology provides extreme temperature charging, minus 30 to 85 degrees C. No lithium can be charged pretty much at below freezing point, with the exception of some lithium technologies that actually have to be heated up, to that to the point that they can be charged above freezing point. They're very, very safe. They're phenomenally safe. Most of them are intrinsically safe, in the solid state space, and provide actually a balance right now between high energy and safety. Right now, the energy on a solid state is comparable to the current lithium ion battery technologies. They have very good temperature endurance, and they can provide, very fast charging, 10 to 15 minutes. Energy density right now is similar to current lithium ion, and it sits in about half of the space or volume. Okay, cycle life is longer than current lithium ion and lithium polymer, and they are available in different configurations, flexible and ultra thin options. They also are very good in a high vacuum situation, and they are absolutely the safest battery technology out there. They have active safety mechanism that provides up thermal runaway, prevents thermal runaway, and at the end of the day, this battery will never catch a fire or explode. Here are some examples of available solid-state lithium cells and modules: FLCB, flexible lithium ceramic, pouch lithium ceramic, and large lithium ceramic battery modules. And then some VDA modules that are actually slated for VDA, and multi-axis bipolar packs are slated for electric vehicles, and also for large energy storage systems. Solid state lithium ion target markets are, where you would expect, pretty much cover all the markets that any current battery is actually uh, sitting at. Some of the steps in the solid state lithium batteries development, we have actually uh, what you may call Gen 3 already, total solid state. Most of the companies out there will have some hybrid solid state solutions, so not to be confused with total solid state, okay? Gen 2 and Gen 1 are not total solid state, so you're going to hear from companies that will claim that they have a solid state battery, but you need to actually take a close look and figure out that actually most of them, or all of them right now, are not the Gen 3, okay? Just a few companies out there, will have Gen 3 total solid state battery. Here's a kind of eye chart, just not, just to say that there's a lot of work being done in the space of developing cathode and anode materials, whether it is for batteries that are liquid based, or even for the solid state batteries. Okay, the materials for cathode and anode, whether it's solid state or liquid based electrolyte, remain the same. There are some of the trending battery applications that are driving the market. Robotics and robotics. Um, which a lot of these, these are some examples and some of the sizes of the batteries that are required, for large lifts and tuggers and cleaning machines that are automated. The batteries can get pretty sizable, and the voltages nowadays for these machines are somewhere from 24 volts to 72 volts, 200 to 1000 amp hours. And then on the small side, you have a small 12, 24 volt solutions with 5 to 50 amp hours. Energy storage systems are also driving the market. Everybody wants to go green, and and when the windmills and the solar, they need to store the energy somewhere, so they can actually, the energy can be sent out during a time when it's needed. So they need very large battery banks, and most of these battery banks are either built on lead or lithium iron phosphate nowadays. New advances, obviously, all of these technologies, drive new advances in BMS battery management on the chipset level dominantly, so the semiconductor companies are actually working very closely with the cell manufacturers to develop new battery management solutions. Upgrades in upgrades in battery production equipment is ongoing, and as well as the in the grading equipment. And that's all I have for today.
Thank you for the great presentation, Peter. That was really good. If anyone has any further questions, please feel free to put them in the chat and we'll answer those. And I am also going to put up a poll, and if you could answer that as well, that would be great. It doesn't look like we have any questions at this time.
Yeah, I think we can pick up questions, in writing too as well.
Yeah, absolutely. And today's presentation has been recorded, so we will be sending out a link to the recording as well as a copy of the slide deck for everyone to look at. So thank you so much, everybody, for joining us today, and feel free to reach out to your FH Sales field sales representative if you have any further questions, and we'll be happy to get those answered for you.
Yeah, thank you for participating too.
Yeah, absolutely. We had a great turnout today. Thank you all very much. I hope everybody has a great afternoon.
Thank you.
Oh, we have
Thank you.
we have one question here, Peter.
Okay.
Can four AHSLA batteries be rejuvenated with home quality disulfators, and how much time does it typically take?
Can you repeat again?
Can four AHSLA batteries be rejuvenated with home quality disulfators, and how much time does it typically take?
That's a loaded question. It depends on the sulfation of the battery. And typically, you have a sulfation when the battery wasn't maintained properly. And there's, we are not experts in rejuvenating batteries, but typically these are used on large batteries where the investment in the battery was high, but as I said, it typically happens when the battery wasn't maintained properly throughout the life, or the battery is already too old to be taken care of that way. Yeah, hopefully that answered your question.
Thank you. We have one more. What distinguishes a solid state battery?
Solid state battery does not have liquid electrolyte. It is a solid piece. It's a ceramic, typically ceramic piece. So no liquids, as other batteries will always have liquid electrolyte.
Great, thank you.
That's the basic distinction.
Okay, that is all of our questions for right now. So if anybody has any further questions, please feel free to reach out to us and we'll make sure that we loop Peter in to get you an answer. And thank you everybody again for joining us. We appreciate everybody's participation and I hope everybody has a great afternoon.